Hello everyone, this is Eren Şahin. I'm a sales engineer from liNear. Today's topic is to apply dynamic cooling load calculation on a Revit building model. I will use models linear building analyze to detect the building and linear building cooling dynamic to apply cooling load calculation in this webinar. First, I will give you some information about our software and the company. For more than 30 years, liNear is in the market for MEP software solutions. We are steadily growing over the years. More than 28,000 of customers are trusting to our products, and every year more professionals start to work with linear solutions, and which make their work more easy and effective. We have 57 industry partners that provide technical data and 2D, 3D models for our product library that can be used in our projects. Many of our customers work internationally, so we provide perfect environment for customers who work internationally. liNear can be used in 7 different languages, and you can also set different languages for the interface and for having outputs, and that allows you to work on the same project data within different languages. Autodesk and liNear are long-time partner firms, so it can be used in 2 Autodesk platforms, AutoCAD and Revit. Also, you can use it in our own platform CAD Insight. In this webinar, we will apply our calculations on a Revit building project. So liNear is not getting used instead of Autodesk products. They work collaboratively for MEP solutions for all MEP disciplines, as you see in here. One of the biggest advantages of liNear in this case is to use same .wg and .rvt format to export your applications. We create a workflow and help our customers to work with highest productivity. To make Revit a true engineering tool, we offer many design, building detection and control tools that combine commands in a time-saving manner and extend for HVAC and piping engineers. Additional tools are available for a constructive and effective collaboration within the integrated design with BIM. As you see, liNear provides a complete solution for an MEP workflow. Starts with preparations and building analysis, load calculation, dimensioning, network creation, and calculation, and also having labels, outputs such as material lists and calculation results. You will see all the steps of the workflow at the user interface while I will demonstrating. Building Cooling Dynamic and Building Analyse are modules that we will use in this webinar. I will use Building Analyse to detect the building with its architectural components and rooms with all of their thermal properties. And we will use Building Cooling Dynamic to apply the cooling load calculation with ASHRAE for our project. As you might already be familiar with, we will use ASHRAE as a calculation method. ASHRAE stands for the American Society of Heating, Refrigerating and Air Conditioning Engineers. And this standard for cooling load calculations is very common and applicable globally. Of course, you can also use the German standard VDI 2078-2. Also, to make this calculation on a Revit model is a big step forward for the BIM implementation. We can share our calculation results directly on the Revit model itself. With liNear tools, you can also export all this data in IFC format that is fully compatible for BIM. Now we will see how to work on Revit. First of all, if you do the planning on Revit, liNear will transfer all cooling loads automatically from Revit to liNear building. By this means, if you have a Revit project that has all of its loads implemented, you can have the results in no time. Now we will see how to detect a Revit project with liNear Building Analyse. First, we open a Revit project with liNear template. Here we will click on Links command on Construction tab for the Architecture discipline. We add our project into the links. And now we will set all floors. At first, we have to create a view for each floor. For that, in the Project tab, liNear asks us 3 questions. First of it, where? So we select where do we want this view. In this case, we select the floor and the building part. Second is what? So we select what discipline do we want to work on. We'll work on architecture. And the third is how. So we choose what type of view do we want to create. We select the floor plan and select all the floors that we want to create views. We can also select another discipline if you want to work on more than one discipline in one view. Here. And then we click on Create Views. In the next step, we will create MEP spaces. For this, we open Construction tab again. As you see, we have a command named Create Spaces. In details of this command, liNear has some options like if it will be made automatically or manually, filling shafts, and tag on placement. For this case, we will leave these options checked and create spaces automatically. As you see, all of it's created. There are also some options for data transfer. We can select room's name and number and also further parameters for spaces. After, when we click on Create Spaces command, all spaces in that floor will be created. Afterwards, we will repeat this command for each floor. Go back here and open these tabs. We can just go to the tab and create spaces automatically. And as you see, all of them created. Before we continue, I would like to show you our parameter manager. liNear Parameter Manager allows you to assign calculated or written linear parameters to your own shared parameters in a mapping table. As you see here, there are lots of linear parameters with their explanations. You can easily select the discipline that you work on and filter these rows. In this case, we work on Building Analyse. When we select Building Analyse, as you can see, there are some linear parameters and some parameters that's taken from the architecture. You will see these linear parameters with the initials of LIN, and the other ones are taken from the architecture. Whichever you place, the first will be activated in the project, and this data will be written into the component. In this case, components are spaces. When you place the parameter that's taken from the architecture in the first one, and then check the space, you see that these parameters are not changeable. But if you select the linear parameter and put that in the first one, for example, for the design temperature heating, click on OK, and then we click on a space, you will see that it's now can be actively changed on the project. So if you prioritize the linear parameter, it can be changed to another value. You always have the option to choose between linear data or the data that comes from any kind of components. After we finish our calculations, we will transfer data from linear building to Revit, and it will be seen at the Revit properties, and you will be able to map these parameters in Parameter Manager too. In this step, we will do zoning. With this operation, we will determine heating and cooling temperatures for rooms. When we click on zoning commands, we see all rooms are listed. If we select levels option, we can see rooms are categorized by their levels. Zones option is easier to use because in this way we can put similar rooms in different floors in the same zone. Then we start zoning. We can mark multiple rooms with the Control or Shift button. See, this is the Control button, and then if you select once in here and press on Shift, the one there, and then you select all the rooms in between. Now let's put office, sleeping, living, and kitchen into the same zone. You see, I use the Control button and I can easily select multiple rows in here, and we move them to the living zone. And we put bathrooms to the sanitary. And then the rest of them can go to the corridors. As you see here, it's quite easy to apply this command. And if we select a room right now, and then right click on properties, it's already open in here. You see that this parameter is added in here in the space. Also, if you want to add another zone category, you should open linear options in here and click on Building Analyse, and in here you can add as much as zone category you want. In here you can just name it in a new zone category, and then you select the temperatures, and then you can just apply this into the rooms. And finally, we pass to the Analyze tab. We close this, and then we go to Analyze tab, and then we click on Building Detection command. And when we click on that, as you see in here, linear building automatically opens. In here, we click on the Accept the building from CAD command, the transfer building from CAD command, and then we select the template. Click on OK. You see it's analyzing the building structure, and then it will transfer all this data into our linear building page. And we say yes. You see that there are some geometrical data are taken from the CAD model. We see the type of the building, the ventilation zones, building unit, and the geometric data, and geometric data for heating rooms, heated rooms in here. And we select OK. You see all these data are transferred into our linear building software. And now let's go back to the CAD and see these errors. You see there's an Issues and Tasks tab. You see there are some overlapping walls in here. You see it says that there are overlapping components, and these are detailed explanations for this error. And when we just see the project in a 3D view and you just double click, you see that this wall is overlapping the one on below. You see in here. So this issue is showing you exactly where this overlapping situation is occurring. So If you have any other collision, any pipe collision or pipe and duct collision, you can see all of these issues on here on this tab, Issues and Tasks tab. Now let's go back to the linear building and select Cooling Load Dynamic. In here, we can see our project with floors and rooms in the tree view. At the right hand side, we can see commands for entering parameters for cooling load calculation. And also on the left hand side, you see the tree view for each floors and each rooms. Also, if you click on here and then go to the results, you see on this screen it's all 0 watts. So that means that we have some problem. And then we go back to log to see what is our problem. You see there is no location and climate data found. Please set location and the climate data. So if we add this value, it will directly be calculated. But first we will see these comments and what are they standing for. First we start with the U values for walls. We must go to the master tables. And then, as you see, in this title for Revit components, there are some different types of doors, floors, roofs, and walls are taken from our project. And these are all calculated for their U values. For example, if we have a wall that doesn't have any U value, let's name them wall 1 and click on OK. You see it doesn't have any U value. Now we have two options. If we use predefined values and select the U value that we want to use, you see it will just accept the value and then do the calculation based on this value. Or when you just remove the check in here and you can just create the wall with all of its layers. For these layers, material tables are already added into linear building. So in here you see there are different materials that you can use to create your walls. There are some materials, and also you can select in some different standard tables too. You see there's a VDI and ASHRAE standard tables to add these layers and create your walls. These are all in linear building with their lambda values, and you can just select one, click on OK, and when you just enter the value for thickness and you create the wall with all of its layers, it will be created. And also visually you can just see it like this. You see all these different materials, you can see them as an image, and also it will be calculated with all of its values. But in this case, delete this one because all walls are already created, because when they are taken from Revit, you see it says this Rev 3587. It's a material that's taken from Revit, and with all of its thermal properties, and the U value is already calculated for this wall and for all the walls in the project. One of the biggest advantages of working with linear is that it gives you the complete solution. Once you detect the building with its architectural properties, you can apply heat loss and cooling load calculations with same data. So you don't have to enter the same data again and again for different kind of calculations. You can just simply complete missing data for concerned calculation and get the results. In this case, we already entered the values for cooling load calculation, and if we want to apply a heat loss calculations, these values will be valid for that calculation too. First, we start with the calculation method. As you see in here, we can select the standard that we will use for the calculation. liNear gives you the option to choose between ASHRAE and VDI standards. Besides, if you click on this pin, you can just move the sub-window separately. Inside the calculation method command, there are other options. From here, we can deactivate some of the internal loads. If you click on U-value purge, you can edit R values for convectional heat transfer. It would show different values for ASHRAE and DIN standards. When you open Calculation Options tab, you can select Calculation Objective between air temperature and operative temperature. Also, you can select Weighting Factor air temperature too. Besides, we can limit heating and cooling capacity of the system. As you see in here, you can just limit the cooling capacity and the heating capacity of the system. From the Operating Profiles tab, we can configure operating profiles for heating and cooling systems. In order to do that, you should click on the little calculator symbol and then click on these three dots to set up the profile. In here, you can either select if the system is open or closed, or you can set up the profile by yourself. You see it seems off, and you extend the profile. You can just set up the values for hours of the day, and then you will have an operating profile. In next step, there is a solar calculation tab. Here we can select between ASHRAE 2005 and 2013. With regard to our selection, we can select values for windows concerning to the incident radiation, interior solar attenuation coefficients, and so on. For example, we can activate the interior solar attenuation, and when we click on the calculator, we can select values for windows concerning to the incident radiation, interior solar attenuation coefficients, and so on from the material tables. In the humidity balance options, we can do the humidity balancing with entering humidity values from this tab. From the lighting tab, we can set up the necessary lighting profile with regard to the daylight factor. Now we will define the location and climate data. For that, we activate the command. When we click on Download Meteorological Data, it will direct us to the Energy Plus website. Here we can select the desired location and download annual climate data in .stat and .epw format. Now, let's select our region. Select in Germany, we select in Berlin. When we click on Download All, it will download all of the climate data into our computer. After we download these values, to transfer these values to linear building, we go back to linear building and select load climate data command. And then in here, we select our file, and when we insert this into our project, you see we can set up our design day. To set up our design day, we can select either between annual, month, and day. When you click on this month and day options, you see all climate data for each month or each days of this month. Also, you can just search for the coldest or the warmest day. So these data are imported into our project for every day of the year. Also, we have the option to create our own design day. When you click on this command, you can just enter all these values for each hour of the day, and you can just enter maximum, minimum air temperatures, dew point temperatures, and month and day of the month, and we can create our design day from here manually too. Now we confirm our selection. Click on OK. You see right now it does the calculation. All of these exclamation points are gone, and now we have our calculation results. Now we will go to the window configuration command. From here we can configure the shading of windows. As you see in here, there are two types of windows that's already imported from Revit. You see the selected window data configuration used in 22 transparent components in 18 rooms. And this one is used in 8 rooms for 8 components. You select a window and then you click on this calculator. You see the shading of the geometry of this shading, and you can see the simulation of the process in hours of the day. And now we will check the internal loads. For this, we just select the room, and here you see a graphical representation of a room, and there are different kinds of data that we can enter. First, we activate the target temperature, and in here you can configure a usage profile for 24 degrees. We gave this 24 degrees of values. You see in here it's 24 degrees. We gave this value in the chat with the Building Analyse with its when we were doing the zoning of the room, we gave this data. And in here you can extend the temperature profile and set up another operating profile for the day. You can select the hours that this room should be cooled to 24 degrees with a usage profile. When we select the enveloping surfaces, you see all architectural components with their geometrical and thermal properties. We took this data from Revit with linear Building Analyse. Also, we can change these properties from here too. If you look at this in detail, you see there's an inside wall and there's an inside door that's subtracted from this wall, and you see the U value for this wall, and when you click on these 3 dots, you can see the U value in here too, and the wall type. And also, if a wall would be a slanted wall, if there was a slanted wall, it will be shown in here. and the others are just quantity and geometrical values in here. And in here you see that the inside wall is adiabatic and the outside wall, exterior wall, is adjoining to the outside temperature. Now let's go to the lighting. When we open this, we can add a lighting load. Just click on the list and then click on these three dots, and you see in the material tables, you see there are different kind of lighting cooling loads: compact fluorescent fixtures, normal fluorescent fixtures, circular fluorescent fixtures, and so on. And when you just select a lamp and click on OK, it will calculate the load and add this into the project. If you want to delete the strobe, you can just select it and press on F6 button on your keyboard. In here you see there's already a load added into this load, and it has a profile set, usage profile set. When you click on this, you see this office lighting from 6 AM to 11 PM. When you go to details, it's already set it up, and this values is also taken from Revit. When we go to machinery and devices, you can add this kind of load from here. You can just select it and open it, and you see there are different standard tables like before, and you see all this machinery devices that can be added, imported into our project. And when you add it, it will also calculate the load and add this value into the project. But also in here you see there's already a cooling load added, and it's from Revit. From the infiltration, we can add airflow rate value or infiltration from material throughput and add this load into our project. We can also configure the usage profile for infiltration too. And now the occupants. When we add a new occupant, we can add these cooling loads from people based on their activities or air velocities. When we add these loads, they will be calculated and added into the project. If we want to assign these internal loads in an easier way, we can go to Project tab and we can select the Assignment of Internal Loads command. In here, we can group similar rooms and add loads for once to all concerned rooms. This way we can do this calculation a lot faster. For example, we can just group all the offices and we can create a new group, and we can set up an occupant load or machinery load only for offices, or only for bathrooms, or only for sleeping rooms, and we can automatically add this load to all of the rooms in our group. After we insert all these data, we can select the room and see calculation results in detail. As you see here, we can simply get all cooling loads and cooling loads per meter square and meter cube from here. And if we select the project and check the results, we can see all loads for entire project. Now we will have the output of this dynamic cooling load calculation. We start the command and select all the titles that we want to see, and also select the language that we want to have the output. For example, we have title of cooling load per room detailed with and without graphic. It will be better if we select one of it, but for this example we will select all titles to see them. Now we click on OK and see the output. As you see in here, we have a compilation in the first page. You can see all location data, project geometry and calculation settings in here. And in the next page, we see all loads in different titles. Furthermore, we see all outside temperatures and different kinds of loads for each hour in the day. As you see, we have this graphical representation in this page. We can see temperature profile and cooling load in the graphical way. After that, we can see the table of data and graphic for each floor. In the next page, we see list of rooms. There are cooling load calculation results for rooms based on their story. This is level -1, ground level, level 1, and so on. And from here, we started detailed room-wise printout. And this one is the room named boiler. You see all of its enveloping surfaces, and you see all of its loads, cooling loads, and you see there are occupant loads for graphical representation, lighting for graphical representation, and all loads with their graphics. And you see there are other graphics for temperature curve, cooling load curve for each rooms. We are still at the boiler room, and now we are at the washing right room, and it goes like this. For all rooms we have this kind of graphical and detailed room-wise printouts. Let's skip this, and yeah, after we continue, you see there are results for all rooms with and without graphical representation. When we come to the end, we see this room named Technique, and it shows all occupant, lighting, machinery devices and infiltration loads for this room, but there are no graphical representations. So we have either graphical or with graphical or without graphical results outputs in our hand right now. Now let's close this one and go back to linear building screen. Now let's try to update the refresh command. Before we do that, we have to make sure that this is active. This command is the cat connection. When we activate this command, it means that our linear building is interactively connected to our cat file. So let's go back to linear building and click on this refresh command, and you see there are different options. There are options like update room data from the cat, update building geometry from the cat, transfer results to the cat. So we will transfer our results to the cat, not take something from the cat. We already took other data from the cat. Now we did some calculation, and we will transfer this result to cat. And now click on start. We need to save it. Let's save it unnamed. Yeah. Now we transferred this data to here. Now when we click on a room and then open Revit properties and go down, you see this data came from linear building, and this is calculated cooling load for this room is 1817 watts, and this is 54 watts per meter square. And for other rooms, you see all these data also taken, transferred from linear building to our Revit file. So let's go back to the linear building. After these calculations, we can implement a cooling system to our project in a very easy way. We can just simply go to module overview, and then when we select cooling convectors or panel cooling, we can automatically dimension these components based on cooling load values and automatically draw these consumers into our CAD file. We can do the configuration in here, cooling convector selection. You can configure your own general cooling convector, or you can select one of the brands in product library, and you can do the dimensioning automatically for each rooms, and then you can transfer these drawings into the CAD, and you can automatically draw these convectors or panel cooling systems. Now we have come to the end of this webinar. Today we calculated the dynamic cooling load of a project that detected by linear building analyze. We used linear building analyze and linear building cooling dynamics modules. If you have any opinions on our webinar, or if you have any suggestions for topics that we should cover in our next webinars, please let us know. If you need more information about this subject or linear modules, you can reach us with linearturkey@gmail.com. If you want to watch this or previous webinars again, you can follow linear YouTube page. Thank you very much for your participation. I can take your questions now.